Okay, the last homework assignment, 11.7, is on probability. The first problem gives us the probability that event F happens is 0.3, and then it says the probability that event E happens given that F happens is 0.8. Then what's the probability that both E and F happen? Now we have this conditional probability form on the formula sheet that I wrote down. It's right here on the formula sheet. And it says that the probability of event B happens given that event A happens is the probability that they both happen divided by the probability that just event A happens. So they actually give us this. If you compare to what I have here, you'd see that this would be like F. So this would be F. And this would be E. B would be E. So if you just fill this out, the probability that event E happens given that event F happens is 0.8. We're looking for the numerator, so I'll just say that's the probability of event F and E happening, and we have the probability that event F happens is 0.3. So multiply both sides by 0.3, and you get the probability that event F and E happen would be 0.24. Okay, the next problem says 2 cards are drawn from a regular deck of 52 cards without replacement. That's actually key right there. What's the probability that the first card is an ace of clubs and the second card is black? An ace of clubs, there's only 1 out of the deck of 52. That's an ace of clubs, so the probability would be 1 out of 52. And we have to multiply that by the second draw. Now the second one, the chances of a black is usually 26 out of 52, but because you already took a black card, there's only 25 left out of 51 left. That without replacement causes you to have 1 left to choose from. So that's my answer, which if you do that comes out to about 0.00943 if you round it to 5 decimal places. Okay, the next problem says if the letters in the word poker are rearranged, what's the probability that the word will begin with the letter E and end with K? So you have 5 letters here that you're choosing from, and if you're choosing it has to begin with the letter E and end with the letter K, then you have to choose those letters there. So that leaves you then, it doesn't matter what you choose for these letters, so you have 3 choices for the next letter you choose, then you have 2 left, then you have 1 left. So there's 6 total ways to rearrange the letters in which you have E first and K last. Now out of the total would be, if you start over with the total, you'd have 5 to choose from here, 4 to choose from, then 3, then 2, then 1, so that'd be 5 factorial. So there's my answer, 6 over 5 factorial, which is 0.05 if you do that in the calculator. The next problem says, in a survey of 304 people, the following data were obtained relating to gender and political orientation right here. A person randomly selected what's the probability the person's male. That'd be a total of males is 137 out of the total number of people, which is 304. All right, male and Democrat would be 29 out of the total people, which is 304. Male given that they're a Democrat. Male given that they're Democrat, we know they're Democrat, so that'd be 29 out of the total 87 for how many are Democrats. Republican given that the person's male. Republican given that they're male, there's a total of 137 males, so that'd be 78 out of 137. And then female, given that the person's independent. Given that they're independent, there's a total of 43 independents, so female would be 13 out of the 43. And the last question, are the events female and independent? Well, the probability that someone's female and the probability that they're independent would have to equal the probability that someone's female times the probability that someone's independent. This is the math formula for if events are independent. So if 2 events are independent, the probability they both happen is equal to the probability of each one individually happening multiplied together. So the probability that someone's female and independent would be 13 out of the total 304, and that would be equal to the probability that someone's female, which is 167 out of 304, times the probability that someone's independent, which is total of independents would be 43 out of 304. And so if you multiply those together, those are not equal, therefore the events are not independent. Okay, the next problem is problem 5. It says we want to find the probability that we have a black or a face card from deck 52. Here's what I've put on the formula sheet for the union, which is or, of 2 events. If they're not mutually exclusive, so if there's some overlap between the 2 events, like in this case black and a face card, the overlap is there are black face cards, you have to subtract that out because you're adding that twice when you add these circles. So that's why when they're not mutually exclusive, you do have to subtract that out. Like in part A here, we have the probability we're going to use this top formula because you could have black face cards, so they're not mutually exclusive. So that we want the probability that something's black, we'll call that event A, which is half, 26 out of 52, plus the probability that you get a face card. There's 16 face cards out of the deck, but you need to subtract the black face cards, which half of them are black. So the probability that you get a black face card is 8 out of 52. You have to subtract that. That gives you 34 out of 52, which is your answer that you can put here. So I just mentioned that the probability that something's black and a face card, you just count the total number up of the deck. So there's 8 black face cards out of the total 52. So that'd be 8 out of 52. Okay, the next one, black or a 3. Those are not mutually exclusive because there are 2 black 3s in the deck. Therefore, you want to use this formula right here. Probability that you get a black card is 26 out of 52. Probability you get a 3 is 4 out of 52. And we have to subtract 2 out of 52 because that's probability that it's both black and a 3. There's 2 of those in the deck. So that gives us a total of 28 out of 52. Okay, next, what's probability you get a queen and a 3? That's 0. You can't get a queen and a 3. Those are mutually exclusive, 2 different events. But black and a queen you can because there's 2 black queens in the deck out of 52. Okay, the next problem says 57% of homes have garages, 33% have swimming pools, 30% have both. What's the probability that a home for sale has a pool or a garage? So that's union once again, or one or the other. So you add the events and subtract the overlap. So 57% have garages. And we want to keep this as percentages here. 33% have pools, and we want to subtract out the ones that have both, which is 30%. So that ends up being 60. And then if you look at this, so if you look at a Venn diagram here, you have pool and you have garage, and outside of here then would be neither, which is going to be 1 minus the probability of everything in the middle, which in the circles. So that'd be 40%. You just do 1 minus, you know, that they have a pool or a garage. And then for the last one, the probability of the pool but no garage. Pool but no garage would be just this area right here. So we want just this area in here. So we want the probability that someone has a pool, which is 33%. And then we want to subtract out the overlap of both, which would be subtracting out 30. In which case that's just 3%. Okay, the next problem says it gives the probability of E and F, the probability of E given F, and the probability of F given E. Now this is our formula for conditional probability. So I'm going to fill it out 2 different ways with both E and F. So I'm going to do is replace B with E, A with F, and then switch that, and I get these 2 formulas. And now you can use these. So if we're looking for the probability of E, that's right here, and then they give us the probability of F given E, that's 0.6. Probability of both, it doesn't matter which way you write, you could switch these because both just means both, which is right here, 0.27. So you have 0.6 equals 0.27 over what you're looking for. So multiply both sides by x and divide by 0.6, and you get 0.45. And then if you're looking for the probability of F, which is right here, you're given both is 0.27 again, and the probability of E given F is 0.36. So once again, you're looking for that variable, so multiply both sides by x and divide by 0.36, and you get 0.75. And then last, the probability of E or F is this formula right here. You know they're not mutually exclusive because they told us there was an intersection. So that's 0.27, and then this is 0.45, and this is 0.75. So just add them together and subtract the 0.27, and you get 0.93. And the last question, are they independent? Well, once again, on the formula sheet, events are independent if you multiply them together and you get the probability of both of them together, the intersection. So that would be 0.45 times 0.75 would have to equal the probability for both, which is 0.27, and that's not true, so they're not independent. Okay, the next one wants the probability of the sum of 2 dice is 8, so I'm just going to add all of them up. How can you get an 8? Well, you can do a 2 and a 6 and a 2, a 3 and a 5 and a 3, a 4 and a 4. So there's 1, 2, 3, 4, 5 out of the total in the sample space, which is 36, because there's 6 ways to get each one. So that'd be 5 out of 36. If we're looking for a sum of 7, that could be a 1 and a 6 and a 1, a 2 and a 5, 5 and a 2, a 3 and a 4, or a 4 and a 3. So there's 1, 2, 3, 4, 5, 6 different ways. So that'd be 6 out of 36. Next one, sum of the two dice is not 10. Let's find the probability that it is 10 and do 1 minus that. So to get a 10, you could do a 6 and a 4 and a 6, a 5 and a 5. So there's 3 out of 36. Let's just do 1 minus that. So that'd be 36 out of 36. That'd be 33 out of 36. Okay, the next one, we want the sum of the two dice to be 5 or a 4. So that's union. And those are mutually exclusive, 5 and 4. There's no overlap of a 5 and a 4. So we can just add the two probabilities. The probability that you get a 5 plus the probability you get a 4. So to get a 5, you could do a 1 and a 4 and a 1, a 2 and a 3, a 3 and a 2. So there's 4 out of 36. So there's 4 out of 36 plus a probability of 4 is a 1 and a 3 and a 1, or a 2 and a 2. So that's 3 out of 36. That gives you a total of 7 out of 36. Okay, the next problem, we want probability the sum of the two dice is not 9 and not 6. Well, I'll just take the total and minus the probability that we do get a 9 minus the probability that we do get a 6. So that'd be 36 out of 36 for 1 minus the probability you get a 9 is you could roll a 3 and a 6 and a 3, a 4 and a 5 and a 4. So there's 4 out of 36 ways to get a 9. Probability you get a 6 is 1 out of and 5 and 1, 2 and 4 and 2, and 3 and 3. So there's 5 out of 36. So that gives you 27 out of 36 total then.